Hey guys, how are you today? Hopefully everything fine. Happy New Year, upcoming days. Today we're going to speak about very famous question, and especially at the rig site, which you can get at the rig site from the company man, or sometimes hardly ever, but still you can see absolutely same question from the, I don't want to use the word young DDs, but let's say we'll say the people at the beginning of the career of directional drilling. The question is very simple, but when we go through that question to get the answers, we will try to see picture from different side, and especially here we will speak about the side force of the BHA and side force of the motor. Probably when you will open any training material, you will not get the consolidated answer for this question because it's more coming from the experience. So what's the question? For example, you have 8.5 inch hole. Let's say you have a motor with 1.5 degree bend, right? And distance from the bit to the bend about 2 meters. If you just simply calculate how much will be displacement that motor pointing on a side, and looks like when you rotate with this bending part of the motor, looks like it's opening the hole for a bigger size than your hole original. So if you simply calculate the 2 meters multiplying by sine of 1.5 degree, you will see that from the side you will have about the 2 inches. So when you rotate radially 180 degrees in opposite, it will be another 2 inches, so 4 inches in total. And is it possible that bend motor while you're going in rotary after the sliding, opening your hole to 12.5 inch? Is it? So we will try to go ahead and we will see, is it possible or no? So is it possible that motor with this configuration can open the hole during rotating mode from 8.5 inch to 12.5? Basically can, but sometimes when you're drilling, no problem, and then something happened at the rig, right? So you have to pull off bottom and leave the BHA for a while, rotating and pumping. Of course, beat is rotating, right? So you will leave some 20-30 RPM from the surface to just to prevent the stuck points, right? But in this case, if you're leaving this for a long time, let's say depends on the formation, of course, but probably 1-5 hours, everything can happen, right? So you can see then on the logs, especially if you have a caliper or in a BHA, or if you go in by the wire line and the next runs after you pull out the BHA, you can see that some ledges traces in a hole profile. Okay, so yeah, this is possible, but most of the time that thing coming from the washouts. For example, if you're drilling even in a soft formation and you will take then the caliper log from wire line, right, and you want to see, okay, here I slide, here I rotate, basically you will probably not highlight exactly the position of the sliding and rotary, because the motor basically is not opening the hole too much. Yeah, of course it can open just, in a soft formation is millimeters, in a maybe soft formation probably you will get about the inch for both side, but I never seen that you can open the hole to 12.5 inch, and especially that's what the client avoid, right? Because he doesn't want to get some hole enlargement in a well bore, right? Because then he have to run the casing and all this stuff, but he always trying to limit you picking up the bigger bend. But bigger bend for you, of course, is better, because you will be much safer when you pick up the bigger bend. And normally more universal bend is 1.5 for H section. I can say H section, better to take 1.5 and go. But client always trying to reduce this bend, like, okay, can you take something like below the 1? And why he's have some image in a head like this, especially because he's scared that your motor will open the hole to bigger size. That's normally very famous situation. So what kind of side forces we have in a BHA. The first type of side force, let's call this upside force. We can see on a just example of rotary BHA, building BHA, because as you can see here, the two stabilizers. So we have a bit, we have a near bit, probably full gauge stabilizer, the bunch of drill collars between two stops. The second stop is under gauge, and when you have some angle in hole, you can push that BHA and gravity help them to bend, gravity help to drill collars bend down, and you can see like collars is bending down because of the weight on bit, and bit is pointing up. This also creates some force which is trying to point your bit upside. So if you have the perfect condition, and your bit will be much aggressive on a side, so you will get some building rate without any deflection, normal deflection method like a jetting or Mora or like a RSS. It's just will be like dump iron BHA, but it will give you some result, right? So this first, the side force and a BHA, which we can highlight, which is increased with weight on a bit. You push the bend down, you're increasing the weight on a bit, more side force you will get. But this side force will be reduced when you rotate more. As fast you rotate, the BHA become more rigid, so more hard is you have to apply more weight on bit to bend the drill collars, and that's actually coming another the side force, which is compensate this upside force, compensated down. So it's when you're all the BHA trying to back to original like this. So let's recall this downside force when your BHA, when you have already angle in hole, trying to get back to the original. And this is of the metal elasticity material which made your from drill pipe, right? And that's actually compensate this side force. This side force also cutting your dog leg, especially when you're building the angle and when you're coming to the point about the 25-30 degrees, especially in soft formation, and you can see that you're constantly sliding same distance, right? But you're getting about the 20% dog leg less. That's actually this side force work, and this situation will continue almost till you will land into the horizontal. So that's two side forces basically compensate each other. Depends on a formation, the BHA and everything. So that's, if you ask someone about the side force, probably he will start speaking about that. But next side force, which we're going to speak ahead, it's completely different story. So what's this additional side force which we can see in a especially motor BHA? When you open any of learning or training material about the motor and some sliding techniques, you can see that most of the time they drawing how the motor fits inside the hole with bend, something like this, right? When the bit already pointing on some side, when motor just like leaving an angle in the hole. But to be honest, it's not too accurate. Why? Of course nobody went down to the hole, right, to the bottom and see how it looks like. But just geometrically, if you calculate, the motor cannot fit in hole like this. Normally, the first part of the motor, bit to bend distance, coming almost straight, without any much deviation. For example, probably if you have 1.5 degree bend, maybe your like offset alignment here will be about maybe half degree. But the first part of the motor coming almost straight. The back side of the motor is bending, especially your stator adapter, power section, tops up, and some components above. So the first part going almost straight, and back side after the adjustable bend housing ring, everything just bending, and this is a create the force which is pointing you on a side, especially this force in the same direction as your motor scribe line, right? So when someone telling to you, please can you orient the motor on the upside, bit to the upside, and just run in hole in case if you have some hole tights or problem or you have to ream down, the client always asking you, can you put the motor on the top and go? Basically when you do this, you will not pointing the beat up. You are basically just turning beat on some side, and you are orienting this vector of the force. So this force from the bend is actually not really highlighted everywhere, and not really much people thinking about this, and this is very important. So how we can use this side force from the motor bend? Then basically, if you look to this picture, you can see that if I move away the side of the power section, if I push this side, the beat will try to go with more force on this side. And that's actually how it works. For example, if you leave all components above the motor just slick without any stabilizer or something like this, you can see that you will not get the much force over here, even if you have the bigger bend. That's actually also coming from geometrical calculation. Before, like a long time ago in Schlumberger, we had some Excel sheet which was called a dogleg prediction. That was a beginning of calculating the dogleg output of the motor which we have. And this software, let's recall the software, whoever it was, the Excel sheet, so it was giving to you also the force, how's the beat pointing on the side of the wall. And what is pretty interesting, you can find here, if you, for example, take absolutely same configuration of the motor in whole, and you will take the two different options, 1.5 degree bend with a stabilizer above and 1.83 degree bend without stabilizer above, you will see that even with 1.5 degree bend, the side force become bigger because on the top you have the stabilizer. How this affect to your drilling operation and how you can use this force, especially in a time drilling. When you have some fish left in hole, right? Maybe this previous BHA, which was get the stock, break the pipe and leave it in hole somewhere in the bottom. Then they put in for you the cement plug, and you have to go from well original to the new formation. And always problem is that cement is always much softer than the formation. Of course, if cement become hard in a casing, it's always difficult to drill it. But when it's become hard in an open hole, it's always much softer than the formation. And your task is, in this case, that's called a sidetrack. You have to go from the soft cement into the new formation, which is much harder than the cement. So then what you can do, you have to design the BHA with a high as possible the side force from the motor. That is a secret how to do the sidetrack more confident. Like you can be more sure that you will sidetrack anyway. And if you doesn't know what is a time drilling, I will just explain very quick. When you put beat down, orient the tool face, and you pushing just inch per 10 minutes maybe, so depends on the speed, and you monitor how much the formation and cement coming in a shale shakers, and you comparing percentage, and you can see how deep your beat going into the new formation. So that's how you're making the decision to increase the speed or just reduce. But normally you're going like 1 inch per 10 minutes or maybe 1 inch 15 minutes. Sometimes I saw in a very hard formation people doing the first half meter about 1 inch 20 minutes. So it's actually very subjective thing, and it depends on a DD experience and how he see the picture bottom hole, you know. So this side force is very important for time drilling. And in time drilling you cannot push the motor. So for example, let's back to the configuration. 1.5 degree bend with stabilizer, 1.83 degree bend without the stabilizer. Of course, if you push the BHA with a maximum weight and beat, you will get better dogleg output with 1.83 because all components is bending on the side when the beat already entered the formation with a like the first part of the motor. When first part of the motor enter the formation, the back side of the motor bending in opposite because you're pushing them, and you will get better dogleg. But here in a time drilling, you cannot push the beat down. You can't. If you push, the motor will go right to the top of the fish, through the cement and you will not sidetrack into the new formation. So you have to design the BHA with maximum as possible the side force, and this side force help you to stay in one point, and it's not too strong actually, maybe about the couple of 1,000 pounds, but not really much, but it's help you to make some ledge, you know, you pick up back to the bottom and motor always pointing, and your top stabilizer will help you to push the bit into the new formation. That's how it works. It doesn't have nothing common with weight and bit. Just that's it. It's just when you have to drill without the weight and bit, which is called the time drilling. There's very important stuff for time drilling basically. So if that force taking the hours to drill you normal sidetrack, sometimes the half day, sometimes the 2 days you will stay in the time drilling to get some result of new hole. Is it too strong enough to open the hole to 12.5 inch when you rotate? No, it's impossible. So when you see now here the picture of the time drilling and how to use that side force, you for sure will give the answer. Is it possible the hole can be opened to 12.5 inch while rotating in any formation? No, almost impossible. Yeah, formation can be washed out. Normally soft formation washing out very quick. Hard formation is not washing out, but you also slow down there, right? You doesn't have some big LOP. And is it possible that hole can be opened from 8.5 to 12.5 inch? No. There's absolutely no chance. Maybe a little bit, but you can see the side force is not really too strong, especially everyone who is have time drilling practical, he can say 100% sure that that's really tough job, really tough job. You have to spend sometimes days to get that your motor, your bit go into original of the hole, into the new formation. So that's it. What else can affect to the side force? So you can see like things which is called the kids playing in. It's called lever swing, right? Lever swings. When kids in playing like that, and if it's this exactly on the middle, so absolutely same load you have to put over here. But when you're making this on the side, for example, if you move it over here, you will get different result, right? Because it's basic mechanics. So you can put just a couple of kilos over here and you will balance about the tenths of the kilos on this side. So this has actually your force increased. So by this way, when you get motor with very short distance over here, so a short distance you will get from the bit to the bend comparing to overall length of the motor, probably you will get better result of this side force. And how it's calculated, basically you can see over here, the calculation is not giving you exactly the side force, it's giving you dogleg output. For example, you get a motor, right, or the rig, you doesn't have passport or anything else for this motor, slide sheets, how this motor perform in some kind of formation, but you can calculate how much its average will give you the geometrically. So this is your curve, for example, this is your radius of the curve. So if you will cut the motor in two parts, first part it will be power section L1, the second part it will be L2. So between this you have an angle which is bent, right, A or alpha, whatever. So radius will be equal to sum of L1 plus L2 divided in 2 sine A. Build-up rate, so we can call also here the dogleg, but dogleg severity, but because it's in a one flap, we can call it build-up rate also. So 2A divided and sum of L1 and L2, and you will get the build-up rate. This will give you per 1 meter. Then you have to multiply to 30 meters, and you will see the 100 feet or on 30 meters. So this is pretty good formula to use at the rig site, just in case if you have a motor and you don't know how much dogleg it's giving to you, so you can just measure it. and simply calculate, and it's give you average result of the what kind of output you can get from this motor, just average. In a soft formation, of course, it will be less. In a hard formation, it will be more close to this calculation. And if you put some stabilizer on the top, probably you will get less. If you remove the stabilizer on the top, you will get more. So that's it from my side, guys.